Okay, so for this circuit, we have a Y-connected balanced three-phase generator with an impedance of 0.4 plus 0.3 J ohms per phase, and it's connected to another Y-connected balanced load with the following impedance per phase, and the line uh, joining the generator and the load has also another impedance of 0.6 plus 0.7 J per phase. We assume it's a positive sequence, so it's a ABC circuit. And the value we're given is VAN. Okay, so that means it's in Y configuration, the source and the load. So it's going to look something like this. So we have one impedance load here, another impedance load here, and then another impedance load here. And then we have something like this. And then one more down here. Okay, so this is plus minus, plus minus, uh, plus minus. Then it's 0.4 plus 0.3 J, 0.4 plus 0.3 J, 0.4 plus 0.3 J. Then this one it's 0.6 plus 0.7 J, and it's pretty much the same for all of these. Yeah, I'm just gonna put those arrows there. And then for these, it's just 24 plus 19J. Okay, and then for these sources, so this is AN, then this is B, and this is C here. So AN, it's 120 phasor 30 degrees. Then, since this is positive sequence, this one will be 120 a phasor, give me a sec, minus 90 degrees. And this one is 120 phasor minus 210, but that's the same thing as 120 phasor 150. You just add 360 degrees. So yeah, okay. So the first thing it wants is to find the line voltage. So the line voltage is pretty much the voltage between here and here, which will give you VAB. Then we have to find the voltage between here and here, which is VAC. Sorry, VBC, and then the voltage between here and then here, which is VCA. So how you can solve this? So we're here. So we have to find VAB, VBC, and VCA. So what you could either do is get these in complex and imaginary form, and then take this value and subtract it by this value. Because when we start here, when we start here, we're at 120 phasor 30 degrees, and then as we move here, we enter the negative terminal, so we have to subtract this value. So this is what we would do. So we have 120 phasor 30 degrees minus 120 phasor minus 90 degrees. That gives you 103.92 plus 180J. Okay, so pretty much convert these into our real and complex form. So I should have showed that part first. I kind of jumped. So 103.92 plus 60J minus 0 minus 120J. And then that's 103.92 plus 180J. And that is 207.8 phasor 60 degrees. Okay, and then VBC and VCA are easy to find. You just subtract 120. So that gives you phasor, give me a sec. That's minus 60. And then the last one, it's again minus 120. So that's minus 180 degrees. And then you can add 360, which is just positive 180 degrees. Okay, but minus 180 is fine. So now we have our first three values done. Let's see what's next. So also, wait, there's also another way you could do this. So instead of doing this long complex format, what you could do is use the following formula. So if you have an AB circuit, the following formula is true. VAN is equal to VAB all over the square root of 3, phasor minus 30 degrees. And if you have an ACB circuit, it's pretty much the same formula, but instead it's positive 30. Okay. So since we have VAN, we'll put this here times by root 30 because we will put the root 30 here. Then we would have to add plus phasor 30 to get these two to cancel out. Okay. And you would see you would get this value as well. But anyways, so we have the first values done. Now we have to find the line currents. So pretty much the line currents are the currents moving through here. Okay. So we have to find IAN, IBN, and ICN. So to solve for these ones, we need to add up all of these impedance values. So let's get ZY. So it'll be 0.4 plus 0.4 plus 0.3J plus 0.6 plus 0.7J plus 24 plus 19J. And that gives you, give me a sec, 25 plus 20J. And in phasor format, that's 32.015 phasor, 38.66 degrees. Okay? And so pretty much to get the line current, you have to take this value, this voltage value, and divide it by ZY. So it'll be 120 phasor 30 all over 32.015 phasor 38.66. That's 3.748 phasor minus 8.66 amperes. Then the next value is the same one, but you just subtract 120. So it's minus 128.66. And the last one, you do the same thing. Subtract 120. So that's minus 248.66, which is the same thing if you were to add 360 degrees, which is 111.34 amperes.